Hello, friends. Welcome to the ATC Double Cut. Today, we're going to talk about transition zone grasses and a bit of the science behind those grasses. I am very pleased to have Dr. Mike Richardson, professor from the horticulture department at the University of Arkansas, joining the show today. Welcome, Dr. Mike Richardson.
Thank you, Micah. It's great to be here. I'm happy to have a chance to chat with you a little bit. I was going back and looking over the last few years and trying to remember the last time I actually saw you face to face. And I think it was probably in Bangkok in 2019. I don't think I've seen you since then.
That's right. We corresponded actually I think it was in February of 2020, because you were supposed to be going to Tokyo for
Correct.
a Toyo Green seminar in late February or maybe in March or something. And you were like, maybe I'm not going to be able to travel at that time. So, yeah.
Yeah, that trip got canceled. But interestingly, just this morning, I got an email from that same group about possibly coming over this February to do a seminar. So hopefully 4 years, or I guess it would be 3 years later now, that trip may actually happen.
Yeah, that would be cool. That's a nice seminar that they hold. And I remember I went to that, I think, if I remember correctly, when I was a golf course superintendent in Japan in the winter. It would have been the winter of 2001, and I believe Milt Engelke was speaking,
Okay.
if I remember right. But when you try to remember things that are more than 2 decades ago, people and places and times get all mixed up, don't they? So let's talk about some more recent research and more things that are more fresh on our mind. I want to talk a little bit about Greenspeed, or at least we'll start off talking about Greenspeed and the grasses that we can use on putting greens. I wrote a blog post some years ago, and I updated it last in 2021. And that post has a title, Greenspeed Ridgeline Plot and the Work to Produce These Conditions. And I had, from 2011 up until early 2021, I had made 903 measurements of putting green speed with a Stimpmeter under non-tournament conditions. So I excluded all the measurements that I made when greens were prepared for tournaments. And there's a wide range of species that I had a chance to measure on because I had traveled some. So I had bentgrass poa, pure poa annua, bermuda grass, bentgrass, fine fescue, seashore paspalum, cori, which is Zoysia, and Serangoon grass, which is Digitaria didactyla. And I had summarized those green speeds, and the median values were highest for bentgrass, for poa, for bermuda grass. Fescue and seashore paspalum were in the middle, and Zoysia and Serangoon grass were lower. And I know you've done some research with your grad student, Tom Walton, especially recently, right? With some of the newer Zoysia. And I know I always assume that Zoysia greens are going to be relatively slow. In fact, the picture that's in the background, if you're watching this on the video, this is a green at the Royal Bangkok Sports Club, which is Zoysia greens. You visited there in 2019 when we met in Bangkok. And there are Zoysia greens all over East and Southeast Asia, and they've been used for many years in this part of the world. It's nothing new, and the greens are renowned for having a lot of grain and for being relatively slow. Now, it doesn't mean you can't have fast greens with Zoysia, but in general, it's pretty slow because the leaf blades are so stiff. But then there's all these varieties that get tested in the U.S., and you saw the research that was done at the University of Tennessee, and so they're comparing Zoysia against Zoysia, but they never put a bentgrass or Tiff Eagle in that trial. Was it Tyler?
Tyler Carr.
So that was some really interesting research about the grow-in and what type of surfaces were produced with the Zoysia. But the thing that I thought was a drawback with that study. They never compared if you'd managed tiff eagle in the same way or if managed bentgrass in the same way, what would happen in Knoxville. Well, what you've done in Fayetteville, you had laser, which is a really fine bladed zoysia that's suitable for greens. And did you compare that against tiff eagle also and bentgrass? Could you tell me a little bit about the research that was done?
Yeah, the study itself. Well, let me just back up. I mean, we have all three of those species on our putting greens here in Fayetteville. We've had tiff eagle greens for a number of years. We've had bentgrass greens, various varieties for 20 plus years, and then now we've had a laser zoysia green for I think this is going into its fourth season. But when we originally established that laser green, one of the things we did was we established some large replicated blocks of laser side by side with tiff eagle. So we had those two species kind of in side by side, same cultural practices for the most part, conditions, and then that was really kind of the foundation of Thomas Walton's research, where he was going to compare tiff eagle to laser, and we had really probably the biggest objective there, Micah, was to look at the relative shade tolerance of those two species, because we know that Bermuda grass can really suffer from low light conditions, and that was kind of what we were thinking would be maybe the niche for some of these newer zoysia grass types, would maybe be on older golf courses that had very mature, well-established trees and potentially shade problems. So the study was basically a side-by-side comparison of those two cultivar species in this trial. And then we looked at some other things. We had a couple of different mowing heights. We had a tenth of an inch versus 0.125 inches. So that's, in metric would be about, 2.5 millimeters, and then maybe a little over 3 millimeters, the mowing heights. And then we also looked at the use of the growth regulator, trinexapac ethyl. We had that also in the study to see if that was giving us really any kind of, improvement in quality, putting green speed, shade tolerance, whatever we thought we might get out of using the growth regulator. So that was kind of the summary of the study. Now, again, we have bentgrass and other greens there on the site, but we really never did direct comparisons of speed of those two grasses against bentgrass in a control study. Now we're going to do some of that this year.
Oh, nice.
And so we're going to have some replicated plots that we're going to actually look at all three of those, and then we're going to do some work on paspalum as well. So we're going to try to look at some Greenspeed measurements in a little bit more of a controlled study.
Oh, awesome. That will be good. Is that going to be? Is your field day? What day is it this year? August 1? Did I
August
see?
1, yes.
August 1.
The hottest day of the summer.
I got this shirt at the
yeah,
2016 field day, I believe.
You are sporting the Razorback this morning. I didn't notice it until you pointed it out.
Yeah. Oh, we both are. You are too. Yeah. Nice.
Yeah.
That was fun. I would love to go back to that field day again sometime. It's just sometimes it's tricky to get from Bangkok to Fayetteville.
Yes, not an easy way to do that.
Yes. So, if I remember right, the tiff eagle generally was a little bit faster than the laser when they're maintained at the same mowing height with the same primo rates with the same treatments. Did you fertilize them the same, or did you cut the nitrogen on the laser?
We did not fertilize the laser as much as we were fertilizing the Bermuda grass. I'd have to go back and look at those numbers, Micah, but I want to say we were, I think, over the entire growing season about 2 pounds of nitrogen per thousand on the laser, and I think we were at maybe 3 to 3.5 on the tiff eagle. So we had a little bit higher fertility rate on that.
And you found that the tiff eagle had more a longer ball roll distance.
Yeah, pretty much throughout both of the years of the trial, I would say month to month, the Tiff Eagle was always probably a foot to upwards closer to maybe 2 feet in some cases faster than the laser. Now, we did have a few collection periods, and it always seemed like it was kind of late in the season, maybe a September reading that the laser tended to get a little bit closer to the Tiff Eagle in terms of green speeds. And again, I'm not really sure exactly what was causing that, but we certainly saw some dates, especially August, September, later in the summer when the laser seemed to get closer to the Tiff Eagle. Never had faster speeds than the Tiff Eagle, but I remember a couple of months where we didn't have statistical differences between them in terms of speed. We were never able to get the speeds that John Sorokin and Tyler Carr and those folks at Tennessee reported. Usually, the fastest green speeds we saw on laser were probably about 11 feet,
Hmm. Yeah,
which would be fine.
I was surprised. It's like research plots aren't renowned for having like green speeds of 13 or something, and Tyler's plots were getting like 13. I'm like, what's going on? That's crazy. But yeah, I think they were rolling them a lot, and yeah, they had good speed. But it's also
Yeah,
so
we were we
cold.
were
It's so.
we were rolling ours some too, but we weren't really aggressively rolling them. I think we
Mhm.
were rolling them maybe 3 days a week or something like that.
But is Fayetteville warmer, considerably warmer than Knoxville? It,
Probably not actually. I would say we're pretty similar. We've got some elevation here in Northwest Arkansas, and that helps moderate our temperatures a little bit. So I would say Fayetteville and Knoxville are pretty similar in terms of what our kind of summer patterns are.
so you've worked with laser, but not with any of the other new Zoysias for greens.
No, we have not. Back in, oh gosh, I think it was 2013, there was a national turfgrass evaluation program putting green trial that had both bermuda grasses and zoysia grasses in it. And we installed that here in Fayetteville. And unfortunately, we ended up losing the entire trial because we had of the 20 entries of those grasses, and there were also some paspalums in it. Like 10 of them completely winter killed the first year. So now you got all these big dead spots in the middle of this sand-based putting green, which is not very easy to manage. And we replanted it again, and same thing happened the next year. So finally, we threw our hands up and said, "This is not going to work." And it would have been nice because there were definitely some of these newer greens type zoysia grasses in there that it would have been nice to get some at least some preliminary data on how they might perform here, but we really didn't. And then when we got to this project with Thomas, we just decided one cultivar was all that we really wanted to try to handle.
Well, I think laser did the best in that in that NTEP trial, and in fact, I've got a blog post about that too, which maybe I it doesn't. I would have to search for it, and I'm not going to bother searching for it. But there, if you search NTEP, actually, I will. Let me see what happens if I search NTEP on my website. I've got a couple. Yeah. So if you see this one, can you see this, Mike?
I can.
So if we look at I summarized this for the sites that reported Greenspeed, and the Synodon data I averaged across Tiff Eagle, Mini Verde, and Tiff Dwarf. And for Zoysia, I averaged across Laser, Trinity, and Diamond. But Laser was always faster than Trinity and Diamond. And if you look at these, the red lines are Synodon or Bermuda grass, and the blue dotted line is Zoysia. And it's basically, like you said, at all these locations from Florida, from Kentucky, from Palm Springs, from Virginia, from Starkville, Mississippi, from Tucson, Arizona, all through the year in the summer, the Bermuda grass is about a foot faster, sometimes more, sometimes a little bit less. It's faster than Zoysia. And I looked just at the Zoysia specifically with the data from that NTEP, and let's see, laser is the green line. Oh, so now we got laser and TIFF Eagle and Trinity. So TIFF Eagle is the the orange dashed line, and TIFF Eagle is almost always considerably faster at all those sites. So when we see that type of data, that matches very well with what I've observed in Asia, which is that if you have a Bermuda grass green, the ball rolls farther than if you have Zoysia. So I've been surprised at how far north people try to push Zoysia greens in the USA, when I just don't see that there's any reason to do that. Because also there's the seed head issue, which I don't think is solved yet. Can you tell me a little bit about what you see with the seed heads, and if that's what the good management is for that?
Well, I wish we had an answer. I don't have an answer. I can tell you it's a when I talk about Zoysia greens to superintendents, I kind of do a picture session at the end of my presentation, and I call it, the good, the bad, and the ugly from the movie. And so I have a picture of either Clint Eastwood or Lee Van Cleef, or the bad, or the guy that played the ugly. I can't remember his name off the top of my head, but there's some things about Zoysia that I like, but there are some things that are really problematic, and seed heads are one of them. And I don't know if this changes as you move latitudes, as you get farther north into the transition zone. But at least on laser, we've seen we have a huge flush of seed heads early in the spring. It's kind of similar to Myers Zoysia grass, and that the seed heads come out very early, just really as the grass is starting to green up. You start getting this flush of seed heads, and they are extremely stemmy, very similar to the leaves. They appear to have a lot of silica in them, and they're very stiff, and they're very, very hard to mow. And we'll see these seed heads for a period of anywhere from 4 to 6 weeks. They really are disruptive to play or to ball roll. And we're getting ready. We got a project that was funded by the USGA, and we're going to be doing it here, down at Texas A&M Dallas, and then also at the University of Tennessee, where we're going to look at some of these fall applied plant growth regulators, things like Proxy or Ethifon. Aaron Patton kind of worked some stuff out on that with Meyer, and we're going to try to see if we can use those same types of chemical approaches in the fall to try to reduce or minimize these spring seed heads. Is it going to work? I really have no idea, but the first trials will be going out here in a few months.
Yeah, that's going to be really interesting, and it's something that I follow closely, because it seems to me like the Zoysia varieties that have been used in Asia have been selected to be ones that don't produce so many seed heads at a low mowing height in this climate and at these latitudes. But then you bring something over that's been developed in the U.S. at different latitudes, different temperatures. I don't know how it's going to perform here, because these new Zoysias haven't been used so much in this part of the world. But there is a lot of Zoysia here that just doesn't have that problem. But certainly you see with Xeon and with Trinity, when those are planted not so much at green height, but those are planted on fairways and green surrounds and so on in Southeast Asia, they do have a lot of seed heads. But the problem is you've got you've got high temperatures and short days for 6 months of the year in a tropical climate. So you have the potential to have a lot of seed head issues. And I've seen where there are seed head issues, and if we knew what good treatments were, that would be nice.
Well, and I think one of the biggest challenges, and this is it's going to take more than 1 year of data to try to figure some of this out, is that One of the things that Aaron Patton did with his work with Ethifon was he kind of tried to model it against cooling degree days to try to figure out the optimum timing, because I think again, this would be a great dissertation project for somebody to try to just understand some of the biology of floral development in zoysia grass. Because for years, I mean, I guess we weren't smart enough to look, but we would see these seed heads in the spring, and so we just thought they were being initiated and developing in the spring, but in fact they're all initiating in the fall of the year. And so the timing of applying a chemical to try to suppress them is going to be it's going to be critical. But there really haven't been any good studies just looking at the basic biology of that floral development, which would, I think, help steer those projects probably a little bit better. If we knew the exact stage of development that you need to apply the chemical, then you could more easily apply that data to a newer variety that maybe develops a little bit slower or a little bit quicker, and then you could figure that out and then make your applications based on that.
Mm-hmm. I measured, or I counted all the seed heads in the zoysia I have in pots at home for a couple years, and so there's both variety differences and seasonal differences. But the seasonal differences, I'm right now I'm less than 7 degrees north of the equator, so the day length doesn't change very much, and the temperature doesn't change very much. And so when you don't have so much day length change, you don't get a huge flush. They're seed heads all year, but there's more of them when the days are slightly less than 12 hours, and there's fewer of them when the day length is slightly more than 12 hours. But it's not like where you are. You'll have like 9 hour days and then 15-hour days in the summer or something. And when you so the basically it depends on variety a little bit when it's going to develop, but it happens sometime in the autumn when the day length goes from 12 and a half hours down to 11 and a half hours, when it makes that transition.
Mm-hmm.
It seems to be that that's where it happens. And if it's too cold, which happens in Fayetteville, it's too cold at that time of the year, so the seed heads will initiate, but they don't grow enough because it gets cold, it goes dormant. And then in the springtime, when it warms up, as soon as it starts growing, boom, there's all the seed heads. But in this part of the world where it's warm, it's a different kind of phenomenon, and so it's something I've been trying to understand too, and trying to predict when the seed heads would happen. But something that I stumbled across, which kind of goes against what some of the research says. The research says if you put less nitrogen, you get more seed heads. There's a Japanese paper from the Japanese Society of Turfgrass Science journal that says that. But I noticed I got tired of trimming my grass in pots. So I fertilized it less and less. So I'm down now to fertilizing twice a year. So I'll just fertilize in January and July. And as I fertilize the grass less, there's way fewer seed heads. So I think some of the seed head flush that you see is because you've got brand new laser on a green that was established, and you grow it in, and it's young, and it's not really being managed like a mature turf. It's still like, because when people grow in turf, I think they tend to fertilize it a bit more.
Right.
And I wonder if the seed head's under regular management and you cut the nitrogen back, maybe it's not going to be such a massive flush like you've observed. But yeah, those pictures are shocking because the Tiff Eagle is fine, and right next to it, it looks like a forest of discolored turf, because the color, it's not even green anymore. It's white and
It's
yellow
white.
and purple, and yeah.
Yeah, it's like I said, it's definitely part of the ugly, because it's just you can't mow it. It has, like you said, this kind of white, pale, just awful color that would not be acceptable. and of course the ball roll is even more you know hideous than it is you know during the peak of the growing season. So it's
Yeah.
and of course it's always one of those things, Micah, that over the years, especially here in the transition zone, that I have learned is that spring performance of golf putting greens is critically important, because it's really probably when they have the peak of play in terms of people just getting out and coming out to play. And if you have greens like this year, we're experiencing winter kill on some of the greens around here, and fairways and other areas on the golf course. And to start the season like that, it just always gives people you know a bad taste in their mouth about the golf course if the greens are really rough or there's winter kill or whatever. And so that spring performance is really important. And if you have this 4, 5, 6 week period of really rough greens because you can't keep the seed heads off of them, that's going to be a negative that's probably going to be hard to overcome if we can't figure out how to reduce these.
But that Autumn Ethithon app works pretty good on Meyer, doesn't it? On
It
a
does.
Japonica
It's
type.
I would say it's inconsistent. You'll always get some suppression, but some years you'll get better suppression than others. And again, I think it's just strictly a timing issue, and it may be timing related to the fall weather conditions in terms of when you put it out as to how complete the regulation is. But certainly it's the best tool we've got right now in terms of suppressing seed heads.
Well, let's talk about the good things about Zoysia greens now, because there's a reason why they are used all over East and Southeast Asia, because they just blow Bermuda grass away at tolerance of shade when they're mown low. So if you cut at putting green height and you put under some pretty intense shade, and let's talk a little bit about photosynthetically active radiation and daily light integral and that type of thing, so we can put it in context. And you can kind of describe the level of shade that zoysia grass can tolerate. And I suppose that in your studies or in Tom Walton's studies that you found the same thing, that when it comes to shade, the zoysia now all of a sudden is much, much better. But whether you're actually going to be having, in some parts of the world, you have that much shade just coming from the clouds, and then you add trees on top of that, and then all of a sudden you need to use zoysia. I'm not sure that there's so many places in northwest Arkansas that actually get that much shade on putting greens. But do you maybe give us the elevator speech about what PAR is and what DLI units are, and then explain what the good things are about zoysia on greens, and how much better it is than Bermuda grass, and maybe it's similar to bentgrass or something.
Okay, well, certainly, light is one of the raw ingredients that plants need for photosynthesis. And, light from the sun emits a lot of different wavelengths, but there's a pretty narrow band of wavelengths that we call the visible light spectrum that, are the colors of the rainbow. And within that spectrum, there are a couple of bands of red and blue light that the plant actually uses to drive or to provide the energy to drive photosynthesis. And so those wavelengths are called photosynthetically active radiation. And you'll also hear them referred to as photon flux density, is another term that you'll hear people use to describe that. But they're measured in a very kind of a unique and maybe not a very intuitive unit, in that they're measured in micromoles of energy, and then they're measured per 2 units of area, or a unit of area and a unit of time. And so typically when you see PAR radiation being reported, it's in micromoles per meter squared per second. And so that means every second of the day has a unique amount of energy that strikes the surface to drive photosynthesis. And so on a long day, you could have 50,000 different units of energy that actually hit the surface and affect photosynthesis. So if you've got all these different energy units, and all of us are aware that early in the morning, late in the day, the energy is lower because of the angle of the sun. As the sun gets up to solar noon, it's going to be at the highest potential energy level. And then, of course, anything that interferes with sun, clouds, trees, mountains, anything else that might block the sun, is going to affect how much energy that plant is getting during that period of the day. So when I first started working on shade, people would talk about percent shade, of hours of light, or things like that. And while those are somewhat descriptive, they don't really give you a quantitative measure of how much light the plant is actually getting over the course of the day. And so we started using, and we weren't the first to use it, obviously, but we started using this concept of daily light integral, which basically seeks to sum up those 50,000 units of energy into a single number that's called the daily light integral. And so the DLI, or the daily light integral, is basically takes into account lower light in the morning and evening, the effects of tree shade, the effect of shade from clouds or anything else. And you eventually get to a single number that's expressed in moles of energy per meter squared per day, instead of micromoles per meter squared per second.
Right. So it's divided by a million, I think. Right.
Yes, that's correct.
Because if you add together all the micromoles per second, you get the daily light integral, but it's a very big number with a lot of zeros. So if you divide it by a million, now you've got the daily light integral.
That's correct. So this number, one of the things I like about the daily light integral, Micah, is that I think it's a unit, or a number, that's transferable. And that means that, the daily light integral in Fayetteville is equal to the daily light integral in Bangkok. When you start talking about how much energy of light you got, or, Montreal, Quebec, or anywhere else in the world, moles per meter squared per day should be comparable between those locations. Where if you're talking about hours of sunlight, 4 hours of sunlight if you were in Alaska is very different from 4 hours of sunlight if you were in Florida. And so, hours of light or percent shade don't transfer as easily as DLI does. And so we have been working now since 2014. I think that's right, 2014, on studies where we're trying to look at the shade tolerance of different grasses, or the effects of cultural practices and things like that on shade tolerance. And we have kind of stuck with this DLI number as the number that we're trying to really identify. And what we really want to do is establish what's the minimum light requirement of this grass under these conditions, management conditions, or whatever. And so we've done work on everything from Bermuda grass sports fields, overseeded sports fields, bentgrass putting greens, Bermuda grass greens, and now Zoysia grass greens, to try to establish what those minimum DLI thresholds are. And again, that was really one of the main things we wanted to get out of Thomas Walton's master's thesis comparing Zoysia to Bermuda grass greens. I'll see if you've got a question. I've been talking for a while.
Well, that's good. Thank you so much. So I like to think of DLI as on a sunny summer day, if there's no clouds and you're in June or July. If you're in May, June, or July, you're often going to have something about 60 to 65. That's the maximum. So even if you're in Dubai or if you're in Phoenix, you don't hit 75, you don't hit 80. There's not that much light. So the maximum on a sunny day anywhere in the world is going to be about 65, something like that. And then if you're at that same time of year and there's a hurricane that comes through, and the hurricane just sits over you with just really thick clouds. So above that hurricane, it's sunshine, but if you're under those clouds are blocking a lot of the light. When I've measured this in Japan in like a typhoon type condition, where in Japan they have sensors, so it's easy to get these data. You'll be less than 5. Okay, so on an extremely cloudy day in summer, you'll be at 5 or something. But once you know that your maximum is 60, then you start thinking, okay, so if you've got 30, that equals 50% shade. Because you have to think, at some point, you have to think about what level of shade you have. But really, everything's tied back to the DLI, like you say. So, and I've argued for the numbers that I've not done. So I've not done controlled research about this, Mike, but I've just observed how grasses grow, and then I've checked what the DLI is. And I think that for putting green height turf, for warm season grasses, I call 40 a no problem DLI for Bermuda grass. Because if you average 40, that's going to be okay. And for Seashore paspalum, I say it's 30. And for Zoysia at putting green height, I say it's 20. And then you do the research, and you come up with similar numbers. Although for Bermuda grass, I know you're a little bit lower. But the original research was from Clemson, right?
Correct.
And what was the name of that author?
Todd Bunnell.
Todd Bunnell.
Todd Bunnell and Burt McCarty.
That used to be at the tip of my tongue because I read that paper so many times. I used to be so intimidated, Mike, by the terminology. And when I read the photosynthetic photon flux density, PPFD, and saw those units of micromoles per meter squared per second, I was really intimidated, and I thought, I can never understand this. And it took me a decade or more to really jump into it and realize that I should try to understand it. And then once I did, I'm like, you know what? That's just what the machine's recording. I don't need to know what a photon is. I don't need to know what a micromole is. I can figure this out. And so I became not intimidated by the numbers anymore, and I started studying this quite a bit and trying to figure out what the light conditions are where different grasses are growing. Because as I travel around the world and I see like why do grasses perform so differently in Asia than they do in the United States? Dr. Ken Kenworthy was just over here. We took a walk in Bangkok, and we really struggled to find any Bermuda grass, even in a park, because there's just different species growing. But you would expect, it's warm, it's a warm climate, there should be Bermuda grass, but there's just not very much of it because of the light conditions, I think. So anyway, let's go back to what you found with your research. So I just said, here's the numbers that I say. I say 40 DLI is a no problem DLI for Bermuda grass. I'm going to say why I think my number is higher than Todd Bunnell's research and some of the research that you've done. I think you come up with a similar number, like 30 or 32 or something.
Yeah, around 32. That's about what Todd Bunnell reported. Yeah.
And the reason why I think it's because the studies are done in summer, and they're done on a shade stress is not going to kill the grass immediately. But if I would say that if you try to grow it at 30 and try to do that for 5 years, you'll have problems. So that's not a no problem DLI. But if you do the study for 3 months at the sunniest time of the year and the best growing conditions, it can tolerate it for 3 months. But what about the other 9 months of the year? And then so now it's weakened going into the next year and do that and then just keep repeating that. That's why I think the numbers that I have are a little bit higher than some of these shorter term studies. But
So, Mike, I'll ask a question because that's an interesting point. I wonder if too, if if you're talking about Bangkok, does Bermuda grass ever go completely dormant there?
it not even close.
Yeah,
No,
that's what I thought.
it's there's no large patch here. It doesn't even get cold enough for there to be large patch. The soil temperature never drops below about 24 degrees Celsius. I bet the soil temperature never drops below 70 Fahrenheit.
Yeah, so I would assume then, yes, you're talking about, and again, I agree with you. I mean, shade is a chronic stress. I mean, it's one of those things that, once it starts, weakening the plant, it's never going to suddenly just bounce back. It's going to just continue to get weaker and weaker and weaker until, it finally just exhausts itself and can't go anymore. And so I wonder if in more of that Southeast Asia environment is because you have that chronic stress on it basically 12 months out of the year, whereas even notwithstanding that we're trying to do these studies over a 3 to 5 month period, we're also completely dormant for 6 months out of the year when we would have our lowest light conditions, basically during the fall and the winter when we have the lowest light levels in terms of DLI. The grass is not photosynthesizing. So it's not really exhausting those reserves or trying to photosynthesize under a minimal, energy level.
Yeah, if so once the temperature is low enough that the grass goes dormant, I don't care if you're in north of the Arctic Circle and you have zero light, there's no shade stress. So you're right. So the magnitude of the or the cumulative effect of low light is amplified the warmer it is and the more warm days that you have.
Mm-hmm.
So that's something that's really interesting, and the I've always been fascinated with the transition zone and just what grass is going to work the best because uh, you know being a greenkeeper, being a golf course superintendent, it's hard work wherever you are, and in the transition zone, it's it's especially hard work, and I've had a chance to work in regions where we had both warm and cool season grasses, and there's a large part of the world. Well, when I was a golf course superintendent, I was in Shanghai, which should be warm season grass, but we had all cool season. Then I went to Japan. We have bent grass greens and warm season everywhere else. I've worked at Augusta, worked at Old Waverly in Mississippi, which had bent grass greens, and then Bermuda grass everywhere else. So I've had a lot of my work has been my work on golf courses has been in these areas with both grasses. And I still, to this day, am so curious about which one is going to give you the best playing conditions and be the. It's never easy to manage, but just like the because you've got all the winter kill stuff too. See, I've always been places where it doesn't really get cold enough to have major winter kill problems if you go with the warm season. So, what do you think? Like at this stage of your career, I was looking at your web profile, your profile at the university. You've been there, professor at University of Arkansas for 25 years now.
Correct.
So, you've and would you consider that transition zone, don't you?
Absolutely. Yeah, we've on our research farm, we have everything from St. Augustine to Kentucky bluegrass and perennial ryegrass, and everything in between: bentgrass, Zoysia bermuda, centipede, buffalo grass. We've got it all growing here,
And so, for do,
and none of it grows really well.
yeah, so yeah, I saw an interesting article. I've got a blog post about that too, from like the 1953 or 1955 American Society of Agronomy meeting before the crop science division was formed, and but the Turfgrass group put a note in there, and they suggested not calling it the transition zone, but they suggested calling it the twilight zone, which
Yeah,
I thought was good. Like the Turfgrass twilight zone.
yeah. I've also heard it called the crabgrass belt.
So, what after 25 years in that part of the transition zone, do you have a favorite grass or one that you think has the fewest problems? Like, are you in a bentgrass area? Are you in a Bermuda grass area in your mind? Like,
Yeah,
because I
well,
know people are using everything.
I'll give you the 25-year short story. When I first came to Arkansas in the late 1990s, most of the state and most of the populated parts of the state were all bent grass. So if you were down in Little Rock or Hot Springs or over in Jonesboro, Fort Smith, Arkansas, Fayetteville, Arkansas, so basically anything in the northern half of the state, central to northern half was all bent grass. And then when you got down into the deep southern part of the state, they had older tiff green type putting surfaces, but there weren't that many golf courses down there. It's a less populated area, and so you just don't have that many golf courses. But then about, I guess it's been 12 to 15 years ago, as ultra dwarfs started becoming, much more popular, and certainly people were showing that they could produce a much higher quality putting surface than some of the older Bermuda grass varieties. Then people in central Arkansas started converting to ultra dwarf greens, and now it's probably if you went down to the Little Rock Hot Springs area where most of the golf is, I would say it's probably either 50-50 or probably tipping some in the direction of Bermuda grass now. There's not as many bent grass courses. Some of the really high end country clubs are still bent grass, but most of them have converted to Bermuda grass. And then Northwest Arkansas, which is the other large population base, most of the courses up here are still bent grass, and we have a couple of courses that have gone to Bermuda grass. But it's definitely, I would say, it's much riskier to grow Bermuda grass up here in the northern half of the state than it is in central Arkansas or southern Arkansas. And then once you move into Missouri,
And that risk is because of potential winter kill, right?
potential winter kill, absolutely. And so if I were going to pick a grass for a high end country club in Arkansas, excluding a few of the ones that are down in deep South Arkansas, I would still recommend bent grass. And the reason is that you basically have a 12-month season that the grass can be used for play. And, we don't get a ton of great golfing days in the middle of the winter, but you'll get some. So you'll get a 12-month season. And you don't have this risk of losing a huge chunk of your season due to winter kill. If bent grass struggles, it's going to struggle in, July, August, maybe a little bit into September. But even if you have some weak areas or have some areas that are, a little beat up coming out of the summer, it's much easier to just come in and do some cultivation and get some more seed on the ground. And then usually by, the end of the fall season, you're back to good, healthy bent grass. Bermuda grass is a great surface, and the courses that have it here in the state are doing a great job of managing it. I've played on some great Bermuda grass greens here, but that one out of every 5 years, if you have pretty significant winter kill, it really it can really just completely ruin a golfing season, because it's not easy to get those greens back into shape during the middle of the golfing season to get them back healthy again. And so that's one of the things I don't like about Bermuda grass, and especially up here in the farther northern parts of the state. The other thing I don't like about it as much as bent grass is that it has a very short growing season. I mean, oftentimes, we only get maybe 6 months of green grass. So you're playing on dormant turf for the other 6 months. And again, it's a good dormant surface. I'm not saying it's not doable. And I think with pigments and stuff now, people are, making them look a little bit better aesthetically. But I still probably lean more towards bent grass just because I think it's a better all season grass that doesn't have as much of a risk of catastrophic, loss.
in your climate.
Right.
Yeah. Well, thank you. That's very interesting to hear. Yeah, I think one of the challenges with warm season grasses, when you push them into places where it's relatively cool, is one of the benefits is they don't grow so much, so you don't have to mow so much. But the problem is if you get any blemishes, all of a sudden that not growing becomes a huge hindrance because you all of us and you get more weed pressure. So you've got more weed pressure, the divots don't recover, and if you have any disease scars or any damage from winter kill or something, all of a sudden now your short growing season and your inability to really grow in the cooler temperatures becomes a problem. So yeah,
Yeah. One,
it's
one thing I'll also say, Mike, and we haven't done any control studies on this, but one of the things that we use to promote Zoysia grass in this region is that it has better cold tolerance than bermuda grass, especially when we're talking lawns or fairways or anything like that. It tends to really have very little to minimal no problems with winter injury. But we have made some observational or have made some observations, I should say, on laser, and I think it's going to probably have to be covered as aggressively as you would cover a Bermuda grass here in this region. I just think it's going to get winter kill if you don't aggressively cover it during our coldest periods.
yeah. So if you look at where zoysia comes from and you look at the ones that are cold tolerant, so the zoysias that grow in cold areas are Zoysia japonica, which is a really coarse leaf blade, which is used in Asia. In northern Asia, it's used on golf course rough, or up in the mountains, it's used on golf course fairways. And that's the type that typically would be used on lawns or is used in Kansas City or in places where it gets cold, or Philadelphia or something like that. You look at the ones that are fine bladed enough to be used on a putting green and that have that dwarf growth habit that is suitable for mowing at a putting green height. Those are ones that if you see them growing in the wild, that's in Manila, that's in Indonesia, that's in places that don't have any winter.
Right.
And I don't know where the varieties that are now commercially available in the USA for putting greens, where those were collected or what genes are in those plants. But I call these types tropical zoysia, and it's a totally different species. Well, I mean, all of these, all the zoysias can hybridize with each other, but they have been classified as a different species, where this would be a Zoysia matrella or a Zoysia pacifica, and laser is actually a hybrid between Zoysia matrella, I think, and Zoysia
Minima.
minima,
Yeah.
right? So, which I think is from New Zealand. So anyway, the is it from New Zealand? Do you know the
I don't know
minima?
where that minima plant was collected. I'd have to ask Dr. Mbika to see if she
I
knows.
She was one of the first people I asked a year ago or so to be on the ATC office hours, and she wasn't able to join at the time. I need to talk with her because I want to talk with her about the seed head, the biology of the seed head production for
Yeah.
one, and more about breeding and the characteristics of these zoysias. So anyway, yeah, it doesn't surprise me that the ones used on greens. I think people in the United States tend to think zoysia has cold tolerance because the ones that have historically been used in the United States are the types that do have cold tolerance. But there's a lot of tropical zoysia there's no reason to expect that it would have cold tolerance. So
Well, and I think, and we're seeing that this year. We've got two golf courses here in Northwest Arkansas that have Matrella fairways and tees. And for the most part, they've done really well. But this is the second time in the last, it was probably 10 years ago, the previous time, where they also have seen quite a bit of winter kill this past winter, especially in those aggressively managed areas, approaches, collars, some of the tees. Any place that they might have had some shade stress on it during the growing season, they're seeing a lot of winter kill even at that fairway height of cut or collar height of cut. But again, when you get them down to especially a putting green height of cut, then they become even more susceptible to winter kill.
yeah, it's tough. It's a difficult place to grow grass. So yeah. Well, so let's close by you telling me, if you remember, what was the magnitude of the difference when you put the heavy shade stress on Thomas Walton's research with so you put shade covers over the Tiff Eagle and shade covers over the laser, and then you measured what the DLI was.
Correct.
And
Yeah, so we had five different shade treatments in that study, and it basically was, a full sun control, and then we had 20, 40, 60, and 80% reduction shade cloth. And so, again, the idea is to try to figure out at what level of light does the plant or the turf start showing weakness or even failing. And so, what we saw in that study was that with the Bermuda grass, in this case the Tiff Eagle Bermuda grass, we were looking at about 30 as the minimum DLI for Bermuda grass. Okay, 30 to 32, varied a little bit over the course of the year. But when we looked at the Zoysia grass, we were down to about, let me see here. I've got to pull these numbers up. I don't want to misrepresent that. I think I was looking at some bent grass numbers.
I will put a link to this thesis. And
okay,
all the blog posts, so everything will go into the show notes. So anybody who's really interested in checking out all the details, this thesis, maybe Travis Russell's thesis, where they looked at bentgrass shade, and some of the articles that you've published about that. I'll put a link.
So again, Tiff Eagle was a DLI of about 30 was considered the minimum DLI for Tiff Eagle. Laser, we were around 17. So a little bit less than your 20, but I would say, based on what we know about statistics, that's a good ballpark.
Yeah, I think I'm pretty happy to just guess and be within 3 DLI. So that's fine. But yeah, it's a huge difference, because that is a massive amount of shade. Because remember, a sunny day is going to be 60. So that means that you could have an acceptable putting green with 2/3 of the light never reaching the grass,
right.
which is amazing. But it's also amazing to see really nice Zoysia greens in Southeast Asia on a cloudy day, and they're surrounded by massive trees. So they're in tree shade and cloud shade, and the grass is still fine. So there is a place for these grasses. Maybe it's not in Northwest Arkansas, but it is kind of cool to see how different grasses perform all around the world. Thank you, Dr. Richardson, for sharing all of that information with me today. And I'm glad we could finally have a chance to talk here on the ATC Double Cut.
Well, thank you, Micah. It's always good to see you and visit with you, and enjoy following your blog post and your podcast. And so I try to keep up with them as much as I can, because I think you and I think a lot alike. I think a lot of topics related to some of these tropical transition zone grasses. So it's nice to kind of see other people coming at it from a different direction and a different methodology, but we kind of can all, meet at the same basic
Yeah.
point, which is kind of nice.
Yeah, it's fun. I enjoy studying about turfgrass. Anybody who's watched or listened to this knows that I'm kind of interested in turfgrass and in a wide range of things related to turfgrass. But I'm often traveling, and I can't really maintain. And I don't have a staff or grad students or anything to like run a big research program. So I have a kind of a unique research program that's in my mind and doing data analysis based on things that I observe and notes that I make in my notebook or photos that I take and studying what other people are doing and then trying to relate like your DLI numbers to what I see. So it's really fun. I've learned so much from you, and we've corresponded a lot and spent some good times together, especially when I went to the field day in 2016, when you were over here in Thailand in 2019. And yeah, we're about due to meet again. And maybe I I have fond memories every year of that field day and think I should try to make it back. So
Well, we need to make it happen. Maybe we can have you come over and speak at our field day sometime.
that would be good.
Yeah.
All right. Well, we can, when we have another good topic to discuss, we can do it on the show. And otherwise, I'll let everybody go. And I hope you've enjoyed hearing from Dr. Richardson today. And I will say goodbye and sign off now for ATC from Yantakao, Thailand. I'm Michael Woods. Bye bye.
Thanks, Micah.
Thanks, Mike.